So hi, Rex again. This is the video number 2 of lesson 1. And in this video, we're actually going to create a basic circuit virtually. And then after that, we're going to be creating it in Tinkercad. So welcome back to the Arduino course that we're doing for Southville. So now let's go and actually design the circuit, right? So first, you're going to go to tinkercad.com. And you're going to tinkercad.com, and you are going to be signing up and creating an account. After you do that, you should end up here, and you're going to click this button, create, and then you're going to create circuits. Click circuits. So create and then circuits. And we're going to build our first circuit, which is the 9-volt battery. Okay, so we're going to start. You're going to click components, make sure you go to basic, and you're going to drag a battery in, and now you have a battery, okay? And then you're going to drag an LED over here, and now you have an LED. And what we want to do is connect the positive terminal to the anode, but just to make it look a bit nicer, we're going to just flip it. So here we can click flip. So flip, 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 flip. What I want is the positive terminal you can see here. So this will allow us to wire it up. So first, let's wire it without the resistor. We'll just wire it. Positive terminal goes to the anode. And then cathode. From the cathode, we put another wire, a black wire. Any color wire is fine. And we're going to click start. Boom! You see it explodes. Why? There's no resistance. So now let's go and figure out how much resistance. So we're figuring out how much resistance we need. We'll press a new tab. I'll just type into Google Ohm's law calculator to make it easy. Okay, and then we'll click here, Ohm's law calculator, and this will really help us compute the correct voltage. So let's go back to the slides. And we're going to see here, remember, our voltage that our LED can have is 1.2 to 3.6 volts. That's how much it can carry. But we're having a 9-volt battery, and the current is going to be between 10 to 30 milliamperes, right? So what we can put in our calculator is the voltage of our battery is 9 volts. How much current are we going to have? Between 10 to 30 milliamperes. So I'm going to press milliamperes. Let's put a number like 15, or I think we put 10 in the previous calculation, 10. And then we're going to click calculate. So it says put 900 ohms of resistance to get what we want. Okay, so we're going to stop the simulation here. I'm going to press this wire and then press the trash can button. Press this wire, trash can button. We're going to do that again. So we're going to add a resistor, and not kilo ohms, that's K ohms. We're going to go to ohms, 900 ohms, right? So you're going to see here 900 ohms. I'm going to rotate it a bit so it looks a bit nicer. Then we're going to have that. I'm going to press this button to give me a red wire, and I'm going to wire the positive to here. Just click, and then click again. Terminal 1 to the anode. Okay? And then I'll click the black button, and I'll click cathode. I'm actually going to click over here so it makes a nice edge or a nice corner. I'll click here first, click, and then I can click there. So the circuit looks nice and neat. And now when I press start simulation, it lights up. It does not explode because the resistance here limits the amount of current. Okay, so we'll press stop again. See, it's down, it's not lit. And then we press that, and now it's back and lit up. Okay, so let's go practice a little bit more. So that's circuit number 1, and we use Ohm's law. resistance equals voltage divided by current. Okay, and then this is the calculation given. All right, now what we're going to be doing is attaching a multimeter. This is pretty cool, so you can actually monitor the voltage and amperes running through. So let's go back to this circuit and delete. I'll press this black thing and delete it. Okay, and then now we're gonna go bottom of basic. You'll have here a multimeter, multimeter, and press it as such. Okay, so what we want to do is we'll click red so you can see that's positively charged. The current goes into the anode, out of the cathode, and we're gonna click red. Cathode goes here to the positive part of the multimeter, and we're gonna take a black wire to signify ground. I'm gonna click negative. I'll click the corner again, and then a nice line there. So now we've connected the electricity flows here to the resistor, to the LED, to the multimeter, and when we click start simulation, it's the simulation saying you're not actually getting 9 volts, you're getting 7.62 volts and a current of 7.8, which is actually not enough for the LED. So to get more current, I can lower this to maybe 500. And now you'll see that, okay, the voltage still the same. Still, the battery is only producing 7.62. But the amperes, there's more current. It's flowing faster because resistance is lower. So as I lower resistance, the current flows faster. And now you'll see 17.3 milliamperes. So that's our first circuit. It's just a battery, a resistor, an LED, and a multimeter to help you monitor that kind of current and the current and the voltage. Okay. And let's just see again what happens when we remove the resistor. So we're gonna stop the simulation, press the resistor, delete the trash button, red wire coming into the anode, and we'll see what do you think is gonna happen. We'll press start and it explodes because there is no resistance on the wire. It's flowing too fast. Flow. Now it's still giving the same voltage, right? 7.62 out of the battery, but the amperes is off the charts. From 10 it became 900, and our LED can only take out an absolute maximum of 20 amperes, so it exploded because there's 900 milliamperes passing through, and the LED can only take a maximum of 20. That's why we do the simulation before the actual thing, because I can't show you this in real life because the LED would blow up. Okay, and this is the summary of our lesson. Voltage is the pressure or the push force of the electricity. Imagine before turning on the faucet, how much pressure is built up in your pipes. So as soon as you open that valve, water comes out. So voltage is how much pressure there is. Also, if you notice a balloon, when it's really full and you open the balloon, air comes out of the balloon really fast, right? That's pressure. But when there's not, it's a small balloon and you open it, not much air goes through because there's less pressure. So voltage is just electrical pressure. Current, it's the rate of flow. How fast is that electricity flowing? Resistance is anything that slows down the current. So imagine on a river flowing fast, you put leaves, you put a rock, that's resistance. Ohm's law is the relationship between voltage, current, and resistance. The less resistance, the higher the current. You know, it's just a relationship. This is very important that current flows from the positive terminal of the battery or the power source. From positive, it flows to the negative. And when you remember the LED, it had to go to the long leg first or the anode, right? It had a certain direction it has to flow or it's not going to work. And lastly, you need resistors to not burn out your components. So this has been lesson 1 of the Southville course on our basic Arduino. We're not using the Arduino board yet, but what I hope is you got a little bit and you were able to experience basic electrical circuits and you're able to review basic electrical concepts. In the next video, we're going to build our first circuit. So that's it. Thank you very much. See you in the next video.